So now we've got our third and final featured talk for this evening, and it's from a colleague of mine, Martijn Walraven, who's a core developer here at Meteor Development Group. Martijn created Meteor iOS, which integrates native iOS apps with the Meteor platform. He began programming at the age of 9 when his mom bought him a second-hand Commodore VIC-20. He worked with emerging web technologies at a small development company and later became caught up in corporate world of enterprise Java. Who among us hasn't, I guess? Teaching technical training courses to developers. While continuing to work on independent projects, he decided to follow some of his other passions. And that led to a bachelor's and master's degree in philosophy and cognitive science from Leiden University, the Netherlands. He also spent a year as an exchange student at UC San Diego, just a few hundred miles south of us. And in recent years, he's taught philosophy to high school students and has worked on a children's television program about philosophy. Tonight, Martijn is going to be telling us a little bit more about the improvements to Cordova coming in Meteor 1.3. So everybody, please welcome Martijn.
All right, great to be here again. As Nick explained, I'm Martijn Walraven. I'm a core developer here at MDG. And for the past couple of months, I've been working on improvements to our Cordova integration. Actually, we released the first beta of this work yesterday. So this is a great time to be talking about some of that work. But before talking about what's new in Cordova, I'd like to take a couple of minutes to talk about what Cordova actually is. As a sort of one-sentence description, you might say that Cordova allows you to package a web app into a native mobile app. And what does that actually look like? Well, a web app usually runs in a web browser. In the Cordova case, that web browser is actually a web view, a view component that is embedded in a native app. So Cordova packages all your assets, your HTML, your CSS, your JavaScript, your usual web technologies that you use to develop a web app, runs those in a web view, and then packages that all together into a native app that you install on your mobile device as usual. But Cordova has more to offer. Like in addition to just packaging your web app into a web view, it actually allows your web app to access certain sort of device native features. There is a fairly vibrant plugin ecosystem for Cordova. Plugins for core plugins for camera access, geolocation, file access, but also third-party plugins for Bluetooth and various accessories and other features. And your web view, JavaScript running in your web view communicates through a part of Cordova called the JavaScript native bridge to plugin code that actually runs in native code. So that's the basic architecture of a Cordova app. What is Cordova? Well, Cordova is an open source project, an Apache open source project. You may also have heard of the name PhoneGap. PhoneGap was a commercial company that was actually acquired by Adobe. At that point, they decided to spin off the open source part into the Cordova project under the Apache umbrella. So PhoneGap is now one of the distributions of Cordova. Other distributions like Ionic also build on the same open source foundation. So Meteor has had an integration with Cordova for a while. And the idea is that, like other integrations, it, as much as possible, integrates Cordova with the rest of the platform. It doesn't require you to use the Cordova commands or even the Cordova configuration files directly, but you simply use the Meteor run command with some extra options. Cordova project creation then happens as part of the build process. There's also the ability to specify plugin dependencies for packages. But one of the most interesting parts, I think, of the integration is the hot code push. Of course, Meteor has hot code push for normal web apps. If you look at a Cordova app, it consists of several parts. Like I said, the plugins consist mostly of native code. And of course, there's the Cordova sort of infrastructure code itself. But one of the parts of your native app is what you might call the asset bundle. And that contains the HTML, CSS, JavaScript, other assets that, in our case, are actually built by Meteor. And what Meteor allows you to do is sort of hot code push updates to your asset bundle and then replace all your assets by a new version. Reloading your app. This works in development, works great in development, but it's also something that is very useful in production because going through an app store process to actually upload new apps and get them accepted into the app store can be a fairly lengthy process, and this allows you to basically circumvent the app store and deploy new versions of your app instantaneously. So how does this work? And what does that mean for the Cordova integration? Well, in a normal Cordova app, so a non-Meteor Cordova app, the web view actually loads assets from the local file system directly on the device. It uses file URLs to download those access those files directly. In the Meteor case, in part because we want to allow you to reliably sort of swap out asset bundles for newer versions, but also for some other reasons, like supporting client-side routing, we actually use our own file serving plugin. And the file serving plugin communicates with the web view over HTTP and serves an asset bundle, the files contained in the asset bundle over HTTP to your web view. So instead of file URLs, we use a regular HTTP URL. In addition to file serving, the plugin is also responsible for the hot code push. And there are some issues with sort of the old Meteor plugin, the pre-Meteor 1.3 version of the plugin. Downloads can be slow and somewhat unreliable. One of the main issues with sort of the plugin design is that faulty versions, which can occur also because of faulty downloads, may actually lead to an app that is completely unresponsive, that's no longer able to actually update to newer versions, versions where the original fault, the original bug may have been corrected. So that requires users to reinstall the app, and that's not a very good user experience. Because of the design of the plugin, and I'll go into a little more detail later, the old version of the Meteor plugin was also incompatible with WK WebView on iOS. So in Meteor 1.3, there are a couple of improvements. One is that we upgrade our dependencies to the most recent versions of Cordova and the supported platforms. The plugin, the file serving and hot code push plugin, has been completely rewritten. Much more reliable, much more performant. I'll say more about this later. These two things together allow us to support WK WebView by default, and this should greatly improve JavaScript performance on iOS. So a little more detail on the changes. Some of you may be familiar with the old version of the Cordova integration, where the web view actually connects to a sort of pseudo domain, meteor.local, to download the assets. We've replaced meteor.local with a regular localhost domain for several reasons, but one of the benefits is that localhost is considered a secure origin by browsers, by web views, and that means that they won't block certain sort of security-sensitive features. And the old Meteor plugin didn't actually use an HTTP server, a real web server. Both on iOS and on Android, it uses sort of interception mechanisms, request interception mechanisms. That works fine on Android, but on iOS, NSURL protocol, the interception mechanism, is not supported on WK WebView. So that was one of the reasons for replacing that with a real local web server. The other reason was that there is a sort of great framework available for iOS, GCD web server, a really performant web server. And besides allowing us to support WK WebView, it also offers a bunch of other benefits, much improved caching, support for streaming, and that means we now have a local web server on iOS, but we still use the old should intercept request mechanism on Android. The other change in the new plugin is that we've moved a lot of the functionality from JavaScript to native code. In the old plugin, the web view, the JavaScript running in the web view would detect that a new version was available through DDP. But it would then also, from JavaScript, actually direct the whole downloading process. So would download all files using a Cordova plugin, but still sending download requests one by one over the sort of JavaScript native bridge, blocking the main thread in many cases, and also the file transfer plugin, the Cordova file transfer plugin itself had some issues. And then the only task of the Meteor plugin was actually to switch over to the new version when the web view told it that the new version was ready. In the new plugin, the web view is only responsible for notifying the plugin that the new version is available. This is still needed because the DDP connection runs on the web view, and that's where we get the notification of the new version. But from that point onwards, the Meteor plugin in native code is responsible for downloading files using native mechanisms, NSURL session on iOS, and a really great library on Android, OKHTTP. It then notifies the web view when the download is done, and will only switch over to the next reload when the reload actually happens. So this means hot code push is now faster and especially much more reliable. There are a bunch of sort of safety mechanisms built in. We, for instance, validate all assets to make sure we download the right version. We actually compare the hash to the hash in the manifest. Another important improvement is that we only download changed assets. The previous version of the plugin would download all files on every change. That, of course, could be really slow. And we only switch to a new version after page reload. So you never get into a situation where you have an existing web app running that suddenly, when it tries to access assets, gets versions that may be incompatible. So all this means that asset bundles downloaded will be valid. They will be the asset bundles as the server has built them. That being said, there are still situations where that asset bundle, let's say we're now replacing version 2 with version 3, where that asset bundle is actually faulty. There may be JavaScript errors, for instance. So we have an extra safety mechanism that actually listens for the app startup to complete, meaning all callbacks, all Meteor startup callbacks have been executed, and does so on a timeout. So after 10 seconds, if the startup callbacks have not completed, we consider the version faulty. And then we actually revert back to the last known good version, so the last version that did complete the whole startup procedure. If there is no such version, we revert back to the initially bundled version. We also blacklist the faulty version, so we don't attempt to download it again, because otherwise you'd get into a loop. So the Cordova upgrades and the plugin rewrite together allow us to support WK WebView. WK WebView on iOS is a replacement for UI WebView. So this is a view component that displays web content. And UI WebView, due to the sort of iOS security architecture, has an important downside in that it can't use the just-in-time compiler. And the solution for this is WK WebView, which actually runs in a separate process. So that allows it to use the JIT, which means, in many cases, huge performance benefits. There's like WK WebView is available from iOS 8, but on iOS 8, it used to have certain issues. One of those issues was that it couldn't actually load web content from the local file system. This is one of the reasons people haven't upgraded to WK WebView in many cases. For Meteor, because we use a local web server, that's not an issue. So we've decided to enable WK WebView, make it the default on all apps. Cordova, the most recent version of Cordova that we've upgraded to, also requires iOS 8. So that means that WK WebView seems like a safe default. On Android, this is not really a Meteor 1.3 improvement, but something that came out in Meteor 1.2. You can use Crosswalk. Crosswalk is a project that integrates Chromium, sort of the open source basis of the Google Chrome browser, inside your app. It offers a replacement web view on, well, that's especially useful on older Android versions. It's both more performant and is actually more standards compliant, supports newer standards. We have a very simple package that you can add, and that enables Crosswalk. The only downside of using Crosswalk is that the size of your app grows because it embeds Chromium. So that's a trade-off. In many cases, I think it's worth it. And then lastly, something many people have been asking for, Android development on Windows. I feel reasonably secure to say that it's probably coming. Like we have certain platform-specific dependencies in our Cordova code. We already took care of a lot of them, but there were some remaining issues that we just didn't get to. And Stephen Edward from the open source engineering team at Microsoft stepped up, offered to have a look at these issues, and came up with a really great-looking pull request. So I'm hoping to get the pull request into one of the next beta so we can test it more widely. If the results are positive, I think it's something we can get into Meteor 1.3. So for those of you who are interested, it would be great if you could give the beta a try. This is the first beta release that came out yesterday. It's not feature complete. It doesn't have hot code push for Android, for instance. And there are some other missing features. But it would be a great opportunity to get some feedback on this version, especially from people who have existing apps, maybe even production apps. So please give it a try. Respond on GitHub, either to the existing issue or open a new issue if you have specific things you encountered. And with that, I'd like to open the floor for questions.
Questions for Martin?
Yeah.
Is it possible to check scheduled alarms on the phone with the Meteor Cordova?
Is it possible to check scheduled alarms?
Yeah.
I'm not sure about that specifically, but there are Cordova plugins for many features. And if a plugin is not available, you can always write your own. So as long as functionality is available from native code, you can always write a plugin, and in many cases, someone else will have done that. There's no specific protection mechanism. You could always use an HTTPS connection, I guess. And
because hot code push is not something I can program. It comes with Cordova, right?
yeah. Oh, I'm sorry. The question is whether hot code push offers any support, any protection against DNS spoofing attacks. And I don't know of any specific mechanisms here. I mean, this is similar to the situation for normal web apps. I don't think there's anything specific to Cordova. I'm not sure I saw a question there. I think.
Do you have a demo on your computer?
A demo on my computer? Well, I mean, I did record a quick demo of our example app, but I don't have anything new to show, no. I mean, the improvements in Meteor 1.3 are not features that are immediately visible. They really improve existing apps, but they don't add new features. I'm not actually sure. I mean, the downloading mechanism definitely supports HTTPS.
There's like a long
It's not something I've tested, so I mean, if you're interested in this, I would encourage you to open an issue so we can test for this and maybe make the required changes.
Could you repeat the question quickly?
Oh, I'm sorry. The question was about SSL support for hot code push.
We got time for one more question.
All right. I really don't know who was first. I think it was you.
Okay. How granular are the change updates? So if I make changes to 2 or 3 files, am I going to end up downloading all my packages files, etc.?
That's what used to happen with the old version. Now we only download the change files, so it's much more performant. So only actual changes. We also make sure not to copy files on the device unnecessarily. So it's a fairly efficient process.
Could you just repeat that question?
Oh, I'm sorry. The question was whether, like how granular hot code push updates are, whether they will always download old files or only changed files. And the answer is that only changed files will be downloaded.
Thank you very much, Martin.
All right.